Hello, everyone. Thank you for joining us today. My name is Ruth Bridger. I'm the VP Marketing at Xorcom. I'm joined here by my colleague, Leonid Feinstein. He is the CTO at Xorcom, and he will be delivering the lecture, Asterisk Security Threats and Best Practices. Leonid?
Thank you, Ruth. Today, we are going to speak about different threats to an Asterisk-based PBX. We will also discuss what actions to perform in order to protect the PBX, as well as what can be done to detect the attacks as soon as possible. We are not going to give you step-by-step instructions about how to protect your PBX, but rather we are going to tell you about some useful tools that can help you protect and test your system security. Unfortunately, there are many ways your IP-PBX could be attacked. I have classified the possible threats as follows: call stealing via telephony or VoIP trunks. For example, a malicious person can dial into the PBX and then theoretically, by dialing some number combinations, make outgoing calls on behalf of the PBX. Call stealing via VoIP communication channels. Such attacks are usually called brute force attacks that are launched remotely over the internet. The attacker tries different SIP or IIX usernames and passwords in order to register their equipment as an extension of the PBX. Once they succeed, they can make outbound calls on behalf of the PBX. Linux server compromising via SSH or HTTP channels. An Asterisk server can be attacked like any other Linux server. The aim of the attack could be different: accessing the company data network, trivial denial of servers, using the Linux machine as network storage, etc. A malicious user can call your PBX from outside and then dial out to an expensive destination at the expense of your PBX. In order to prevent such stealing, trunk-to-trunk calls are usually prohibited in the PBX. Usually, when you are calling from outside, you can get a PBX extension, but you are not able to get another PSTN destination. This rule should be considered when you are building a dialing plan for your Asterisk server. By the way, FreePBX doesn't allow trunk-to-trunk calling. The exception is DISA, Direct Invited System Access. This feature allows an outside user to call the PBX and get the system dial tone. After that, the user is able to make an outbound call on behalf of the PBX. This is a very useful feature, but also creates the possibility for a malicious user to steal calls. The recommendations here are very simple. Don't use DISA without password authentication. Use long passwords for DISA access. Now we will talk about a popular call stealing method via SIP IIX. This type of attack shouldn't be underestimated. In 2006, the police arrested Edwin Andres Pena, who made over $1 million through his company named Quartz Telecom, selling VoIP access to smaller service providers. The catch was that instead of buying minutes from larger carriers, Edwin, together with Robert Moore, devised a scheme to route phone calls through illegally obtained user accounts on various VoIP providers. As the story goes, Robert Moore made this possible by scanning for H323 devices and trying default or easily guessable passwords on these devices. Although the criminal duo made use H323, similar attacks also apply to SIP/IIX. Let's take a look at the typical web attacks steps. The first step is PBX IP address and port discovery. There are various tools which can do this, including typical port scanners such as Nmap. One may also make use of SVMap, which is part of SIP vicious tool suite. Let's see how it works. Now I'm going to run SVMap utility that will scan my local area network. This is the host address range. The process will take about 5 seconds. Let's see what the utility will find. Okay, as you can see, SVMap has detected about 20 different SIP-capable devices, including Asterisk PBX, including 8 something, I don't know even what is it. Detected Polycom SIP phone, it detected Grandstrip SIP phone, Earlink SIP phone, and it took, as you saw, about 5 seconds. Once we know the Asterisk IP address and accessible SIP port, we can switch over to the second stage. In the second stage, it is desirable to find out which extensions could be registered on the PBX. The best method for identifying existing extensions is to record the response for a request to a non-existent extension and then look out for requests that produce a different SIP response code. Fortunately, Asterisk addressed this cracking method, and if a special parameter is defined in the SIP configuration, then Asterisk rejects invite or register requests with an identical response, regardless of the rejection reason. This trick significantly hampers the brute force cracking attacks because the attacker has to check all possible extension numbers with full dictionary of possible passwords. Now I am going to show you how the extension scanner tool called SVWAR fails to discover Asterisk extensions. Okay, so I am going to run SVWAR utility that accepts 2 parameters. One parameter is a range of possible extension numbers, and the second parameter is address of my Asterisk server. You will see that SVWAR will stop to work almost immediately. Oops. Okay, so we see that the reason for it found nothing. What does it mean? First of all, SVWAR tries to register one, most likely not existent, randomly generated extension number. It could be something like 20,568, so something unusual, and learns the received response. If the received response is different than so-called 401 authentication required response, then SWWAR starts to register the extensions defined in the command line parameter. Each time it compares the received response with the response received for the not existent extension. In our case, Asterisk responded with the authentication required for one response when SWWAR tried to register the first not existent extension. Because of that, SWWAR decided to stop the process because there is no chance to differentiate between existing and non-existent extensions. Thank you to Asterisk developers. After an attacker has a list of existing PBX extensions, he will try to find passwords for them. This is the hardest part of PBX hacking. Usually, a dictionary of different passwords is used. The cracking program tries to get a positive authentication response from the PBX by using the passwords in one-by-one basis. A malicious user located on the inside theoretically could get an excerpt of SIP trace with a valid authentication request response messages sequence. Then a kind of offline cracking software could be used. Such software extracts the parameters used for building the authenticate response message header field and then tries to find a password that allows recomputing the exact MD5 digest. In this case, you will not see a lot of warning messages in the Asterisk log. And therefore, it will be more difficult to detect this attack. Let's see how the SWCrack program will find out the password for extension 308 on my PBX. Okay, so I'm going to run SWCrack utility that requires at least two parameters: IP address of Asterisk server and extension number or SIP username. The password for it should be find. The process will take several seconds. Okay, as you can see, the utility very quickly discovered the password for my extension. As you can see, the password is the same as the extension number. As you know, many people does the same mistake. Now let's take a look at the Asterisk log in order to see if is there any track of this attack. In the Asterisk log, you can see a lot of notice messages that say that registration from 308 failed because of wrong password. Okay, there are really a lot of such messages. I just scroll up and down to show you that it's really big amount of messages. But finally, at the end, you can see that extension 308 succeeded to register. It means that SWCrack has discovered the password and succeeded to register the extension. This is the final stage of a PBX hack job. The attacker has registered an extension and is able to make calls through the PBX. Most likely, you will discover it only when the next telephony bill is received. This is what happened with one of our customers. To his surprise, he received a bill for about 11,000 minutes of international calls to very expensive destinations. An Asterisk server can be attacked like any other Linux server. The intent of the attack could be different: accessing the company data network, trivial denial of service, using the Linux machine as a network storage, etc. The malware software may infiltrate via different Linux networking services such as SSH or HTTP. The viruses pose a potential, although minimal threat to Linux systems. I saw at least 2 Asterisk servers infected by an unknown virus. The virus seemed to have some bugs because many infected binaries simply stopped working, and therefore the virus was quickly discovered. Unfortunately, we didn't have enough time to investigate it, and also we didn't know how to remove it. Viruses, as you know, are not very widespread in the Linux world, and many Linux people simply don't know what to do with them. So we just helped our customers reinstall the software and change the default and very trivial SSH password 123456 to something stronger. If there is an FTP server installed on the PBX, then theoretically it can serve as network storage for keeping and exchanging videos, pictures, etc. Also, even more dangerous than that, the PBX or even a poorly protected Linux-based SIP phone can become a tunnel for accessing the company data servers. Don't forget that nowadays SIP phones are actually computers with an operating system and many run network services. So a SIP phone also could be used as an intermediate station for attacks on company data servers. How to protect the PBX? First of all, we shouldn't be paranoid. There are countless methods to harden a server, but each method has its price. Obviously, it's not so convenient to maintain a strongly protected server. It is impossible to connect it to it from any IP address. It is necessary to remember complicated passwords, etc. You know, nobody likes to pay for insurance, but all of us understand that we don't have an alternative. Fortunately, 99% of attacks are the simple attacks, and there are simple means that can be employed to prevent them. In order to protect your SSH communication channels, we recommend to use public-private key authentication instead of password authentication. Also, create a user account and disable direct login as root. You can disable it very simple in SSH dconfig file. The parameter name is permit root login. When it will be possible to connect to the PBX as not root user and then just became a super user by using su command. Also, we suggest to restrict the source IP addresses that are allowed to access the server. The good protection can provide just disabling the default SSH port, which is 22 TCP port. You can either arrange port forwarding on the NAT router or change the listening port in the PBX SSH server configuration. Some customers with higher security requirements separate the VoIP network from the data network. Dedicated cabling network not required. VLAN technology may be used instead. It helps prevent company data servers from direct access from potentially vulnerable VoIP devices. HTTP communication. Also, don't expose the PBX web server to the internet. Instead, use SSH tunneling for the PBX web-based management interface. Windows users can create SSH tunnels very easily using PuTTY. Let's see how it could be done. This is SSH session to my Asterisk server. In order to create tunnel that will connect my computer to the HTTP server that is running on Asterisk server, I click on the upper left corner of the PuTTY window, go to change settings, go to connection, SSH, tunnels. Now, I define the source port. On this port, in my case this is 3000, PuTTY will listen on my computer for connection request from me, actually from my web browser. Destination. Here we define what should be done on the remote side of our SSH tunnel. So here we define IP address and port number where my connection request should be forwarded. In our case, it should be forwarded to the same computer where Asterisk is running, but to port 443. This is SSL port of Elastic's web management interface. Okay, so here I'm reading 127.0.0.1 and port 443. Don't forget, click Add button and then apply. Now I open my web browser and I write HTTPS 127.0.0.1 3000. Okay, so I get to my Asterisk web management interface. Okay, in the same way I can create another tunnel that will connect my web browser to a SIP phone that is connected to the local network along with my Asterisk server. So I'm going to the same place, change settings, connection SSH tunnels, and define another source port. Let's take for example 3002, and here I define IP address and port where my tunnel should be connected. So I know that IP address of the SIP phone that I want to connect to is 192.168.0.185 and port number is 80. Click the Add button and apply. Okay. Come back to our web browser, and here I enter HTTP 127.0.0.1 port 3002. Okay, so as you can see, I get my SIP phone web interface. Pay attention what is written here. You see, this is local address. This is loopback IP interface 127.0.0.1. Okay, and port 3002, which is actually entry point of SSH tunnel. Okay, so very trivial recommendation that for sure everybody heard a lot of time, but again, it's very simple, but it's very good practice. Don't use the default passwords. Don't use simple passwords. How we can secure our web communication? First of all, it's recommended don't expose SIP and IX ports unless it's absolutely necessary. Use a restriction for internal web extensions. It will allow use of weak password or no passwords for the internal extensions. Use strong passwords for remote extensions. You see a screen grab from FreePBX SIP extension settings. As you can see, this extension is restricted to local IP address range. And for this extension, it's not necessary even probably to define any password. It is also possible to use more sophisticated intrusion detection systems. For example, fail to ban. It scans the log files and automatically updates firewall rules to reject the IP address. Fail to ban can be installed on the same server as Asterisk. Another intrusion detection option is snort. In contrast to the fail to ban, snort doesn't scan the log files but rather directly inspects network packets. Snort can be installed either on a separate computer or on the Asterisk server. Let's take a look at fail to ban features. This is log-based brute force blocker. It runs as a daemon. Unlike cron-based tool, no delay before taking action. It can use IP tables. It can handle more than one service, such as SSH, Apache, SIP traffic, etc. It can send email notification. It can ban IP either for a limited amount of time or permanently. Now, snort features. Snort may be run in different modes. Sniffer mode, which simply reads the packets of the network and displays them for you in a continuous stream on the console. The packet logger mode, which logs the packets to disk. Network intrusion detection system, NIDS mode, which allows snort to analyze network traffic for matches against a user-defined rule set and performs several actions based upon what it sees. In this mode, snort doesn't change any firewall rules, so it just detects intrusion and put events in some logs, database, etc. In this mode, snort obtains packets from IP tables instead of lib pickup, and then causes IP tables to drop or pass packets based on snort rules that use inline-specific rule types. So, to summarize, today we have reviewed different threats to an Asterisk-based PBX. We have discussed what actions can be performed in order to protect the PBX, as well as what can be done to detect the attacks as soon as possible. We spoke about how to protect against call stealing via telephony trunks and VoIP channels. We also spoke about possible intrusion attacks via other IP networking services such as SSH and HTTP. We provided a brief view of the tools that can help you protect and test your PBX system in order to prevent attacks when possible and detect them quickly when prevention was not possible. Ruth?
Thank you very much, Leonid. You covered a lot of material, and I'm sure we have some questions.